this with the previous thing, the only difference you see, in the previous case, CN was connected here. But I want, if you connect CN here, both the capacitors are connected to the same winding. There is a chance that the connection sometimes may not work properly. So what I do, I center trap the secondary and I connect CN in the secondary side for safer reasons. So instead of connecting CN to the primary, I am going to connect CN to the secondary. So in the modified Hazeltine neutralization method, CN is connected to the lower end of secondary coil of the next stage, whereas it was connected to the lower end of primary in the Hazeltine method. So this is a very small change in the diagram which you have done, and this will ensure that it will work perfectly for all the conditions. So otherwise, the circuit you see, I'm using a transformer at the input side. So input and amplifier are isolated. I am using a voltage divider bias. I'm having a DC power supply, and I am having a tuned circuit. I'm having a bypass capacitor CE, emitter resistance RE is there. So I'm having all these combinations. Okay, so other things are same. Only thing, instead of connecting the other end of CN to the lower portion, center tapped portion of the secondary of the transformer. So which is going to ensure that my capacitance will work properly even when your VCC is going to change, and it is going to provide a very high stabilization for my tuned amplifier. So just by switching one connection, I find that this is going to help me in achieving a higher stability. So however your VCC is going to change, since your VCC and primary are connected, so any change in VCC would be affecting the previous circuit because my CN was connected here. But now, since I'm moving CN to the secondary center tapping, any change in VCC, if VCC is changing, so this change in CN will not be there because I am connecting CN to the secondary center tapping. So this way I can make my working of CN completely independent of VCC. So VCC will decide your biasing points of your transistor, right? So VCC, the biasing coordinates, everything will influence the working rate. So if I want to make a component independent, so ensure that the component is completely away from VCC or it has no effect of VCC on your circuit. So that way I connect the CN to the secondary where there is no interference of VCC. So this circuit is ensured to work perfectly for any variation in VCC. It is going to provide a very high stabilization, and the circuit for the same is shown in the figure. So this circuit is here, you see here. So that is the modified Hazeltine neutralization, or it is called as Neutrodyne neutralization method. So these two of the neutralization techniques what we have in our syllabus. The neutralization itself is a theory where you discuss how we are going to cancel out oscillations. Before that, why we need neutralization? Because the stability becomes a question mark. So stability of the tuned amplifier is also going to be one theory topic where we discuss how the negative resistance is going to impact your amplifier. And neutralization is one technique where you present the design procedure for cancelling out the potential positive feedback oscillations. And we have two methods, Hazeltine neutralization and Neutrodyne neutralization, for carrying out the stability of a tuned amplifier at the respective frequency of operation. So the